Penguin Random House Audio presents The Art of More: How Mathematics Created Civilization by Michael Brooks. Read for you by Nick Afka Thomas. Note to listeners: this program includes a downloadable PDF that contains formulas, illustrations, and a table from the book. Author's note: all are welcome here, whether you love mathematics, have always hated it, or just wish you understood it better. There's a whole rainbow of experiences with this subject, and, right from the start, I wanted this book to be accessible to every part of the spectrum. To this end, I've kept things as straightforward as possible, but I've occasionally thought it was worth investing a tiny bit of effort to properly understand something. That means there are bits of actual maths in here. Some graphs, equations, and calculations that I'll walk you through gently. But if any of it bothers you, and you don't feel like being bothered, just skip that bit. Life's short enough already. Introduction. Why our skill with numbers is the greatest human achievement of all. In June 1992, the American psychologist Peter Gordon traveled to a village of leaf-thatched houses on the banks of the Meiji River in Amazonia, Brazil. He was there to meet his friend Daniel Everett, who was living as a Christian missionary among the remote and isolated Piraha people. Everett had told Gordon that the Piraha have a somewhat relaxed attitude to numbers. Essentially, they just don't bother with them. Intrigued, Gordon had come to find out more. Using a clutch of AA batteries he had brought with him to the jungle, Gordon set up an experiment. He laid some out in a line and asked Piraha villagers to create another line next to it with the same number of batteries. 1, 2, or 3 batteries was not a challenge, but the villagers struggled to correctly match a line of 4, 5, or 6. 10 proved almost impossible. They had the same problem when asked to reproduce marks made on a piece of paper. If there were 1 or 2 marks, they could do it, but 6 was the most anyone managed. The Piraha, it seemed to Gordon, didn't have any kind of handle on numbers. Probably because they didn't need to. Their way of life meant that their brains had never had any reason to form number concepts. To most of us, it comes as a surprise to learn that people can happily get by without numbers. That's because we unconsciously appreciate that numbers are deeply embedded in our daily lives. What we don't appreciate, until it is brought to our attention, is that our way of life, our institutions, and our infrastructures were built on numbers. Whether we're talking about business, housing, medicine, politics, warfare, farming, art, travel, science, or technology, almost every aspect of our existence is built on mathematical foundations. And that is all the more astonishing when you appreciate that mathematics didn't have to happen. When it comes to a natural ability with numbers, we're no better off than many other species. Humans are born only with what is now known as an approximate number sense. This means that, in its raw state, your brain doesn't bother specifying when there are more than 3 of something. So, when a human baby sees 4 apples, the sight is logged as many or more. Our natural counting system is 1, 2, 3, more. The brains of rats, chimpanzees, birds, and monkeys also use an approximate number system. Reward a rat for pushing a lever 5 times, and it will occasionally return to the apparatus, performing a varying number of pushes close to 5 in the hopes of a treat. People have managed to teach chimps to do more sophisticated number-related tasks, remembering sequences of numbers, for example, and they can sometimes be better at this than untrained adult humans. But the training requires rewards. Chimps don't start to do maths for the fun of it, and neither did you. You learnt to count because of cultural pressures. Those pressures came from an interesting place, a deeply ingrained cultural wisdom that tells us that mathematics matters. The Tudor mathematician and mystic John Dee called mathematics a strange participation between things supernatural, immortal, intellectual, simple, and indivisible, and things natural, mortal, sensible, compounded, and divisible. This might seem like mumbo-jumbo, but mathematics is supernatural in that we have used it to go beyond the natural. Developing maths allowed us to dissect and dismantle nature's patterns and symmetries and, like gods, recast them in ways that serve our interest. Through maths, we shape the world around us to give ourselves a better experience of being human. The first leap was to count to 4, and eventually we found ourselves establishing civilizations. Once our brains are schooled in the art of more, they become able to cope with complicated abstractions. They grow comfortable in a world where numbers can be applied not just to things that need counting, but to shapes, points, lines, and angles. Geometry, in other words. This gives us the ability to reimagine, on paper, on a wooden sphere, or just in our minds, a huge and complicated object like the Earth, say, and to navigate our way around it. We can also reimagine numbers, the ones we know and the ones we don't, as symbols that we can manipulate to control and re-engineer the world, performing astounding feats of ordering, optimization, and transportation. That's algebra, in case you were wondering. We can even do calculations that predict the future that will result from the change that is happening around us. We call these calculus, and they enable us to realize a range of human aspirations, from free market capitalism to moon landings. We learn this maths, or we are supposed to, early in our lives. In school, we are assured that maths is an essential skill, a passport for success, something that we have to pick up. And so we obediently, though often reluctantly, gather the tools of maths and do our best to learn how to use them. Some enjoy it, most don't. And then, at some point, almost every one of us gives up. Few of us will learn any more maths after that moment. Over the ensuing years, our hard-won skills wither away, and we are left with only the basics at our fingertips. Without technological assistance, such as our mobile phone's calculator, an essential tool for dividing up restaurant bills these days, we find ourselves able to reliably add and subtract only relatively small numbers, and maybe to multiply and divide a little. The rest is lost. We might even become maths-phobic, actively avoiding any encounter with numbers. Or we might just think of mathematics as beyond our grasp, something that's not for me. If that's you, I hope this book will change your mind. The extraordinary achievement that is mathematics belongs to everyone, no matter how good they are or aren't with numbers. We all benefit from the way the human brain has put maths to work over millennia, and we all have the right to engage with it, whatever our educational achievements. Why shouldn't you be able to see how Newton's calculus is as beautiful as the Taj Mahal, and why there is as much beauty in the Babylonians' algebra as there once was in their hanging gardens? And the proper appreciation of mathematics is not just about some equivalence to what we traditionally see as beauty. It's about seeing how we built the things we value as beautiful. Wherever we look in art or architecture, whether it's one of Vermeer's paintings or Istanbul's majestic Hagia Sophia, we find mathematics facilitating its creation. This influence goes beyond aesthetic issues. The human story is itself inextricably interwoven with mathematics. Columbus's journey to the Americas relied on understanding the properties of triangles, and the modern corporate world is a consequence of what a grasp of numbers makes possible. Mathematics provides the sculptor's chisel that shaped the Renaissance, and the ammunition that has engendered centuries of military success. It is the interpreter that allowed people with no common language to establish mutually beneficial trade, and the fuel that took humans to the moon. It is the spark that electrified the world at the beginning of the 20th century, and the power behind every throne in the ancient world. No wonder King Shulgi of Ur was worshipped for his mathematical skills 4 millennia ago. I learned none of this at school. I did learn how to pass all my maths exams, and sometimes how to apply that maths in order to work out the acceleration of a car or the force required to send a rocket into orbit. But I never learned what mathematics had done for us as a species. or how we came to invent it.
Sample complete. Ready to continue?